Welcome to this pre-study video presentation prior to the NODEFIC NATO logistic training. This presentation is one of 5 short presentations that all are mandatory before applying to the NODEFIC online digital training. Those of you who has completed the online digital training may apply to the 1-week practical and functional orientated NATO logistic training at NODEFIC in Oslo, Norway. Please find more information at our webpage. After this introduction, you should be able to recall the 20-foot equivalent unit container, the ESO standard for containers, and the different modes of transportation. An intermodal container is a large, standardized shipping container designed and built for multimodal goods transport. Intermodal indicates that the container can be moved from one mode of transport to another, from ship to rail to road, without unloading and reloading the contents of the container. The intermodal container came into use in the 1950s and changed the world of commerce by providing a standard low-cost method to transport goods internationally. The container platform can be used to carry dry cargo, fluids, gases, temperature-controlled cargo, etc. In addition, a container can be used as a platform for office buildings, medical facilities, living accommodation, etc. You are only limited by the fantasy. 20-foot and 40-foot containers are the most common sizes of containers. Both forklifts, reef stackers, and trucks are built to be able to handle these kinds of containers. The International Standard Organization published an ESO standard for containers in the late 60s, and in the 1972, the International Maritime Organization, IMO, approved and implemented the International Convention for Safe Containers, CSC. Typical ESO shipping containers are manufactured with identical size specifications in terms of exterior height, exterior width, and exterior length. The standardization of containers and the adoption of the ISO specifications is to ensure that all equipment handlers, chassis, rail cars, and slot spaces on vessels will accommodate all containers. The Convention of Safe Containers is an international regulation developed to cover containers used for international transport. The containers must have a valid safety approval plate called CSC plate. This is the only guarantee that the container is safe to travel. Only containers transported via air are exempt from this regulation. The convention that introduced the CSC plate aimed at achieving the highest possible level of safety of human life in handling, stacking, and transportation of containers. The original safety certificate is issued by the container manufacturer. However, once the container is under ownership, the owners are responsible for the safety certificate renewal. The renewal takes place by a certified inspector after 5 years initially, and then every 30 months thereafter. The 20-foot equal unit, TEU, is a unit of cargo based on a volume of 20 foot long and 8 foot wide container. The height of the container is not standardized and vary from 4.25 foot to 9.5 foot. The most common height is an 8.5 foot container. The following must be taken into consideration by planning the stuffing, the loading, of a container. Floor loading. Load spreaders should be used to distribute the weight of the load across a larger area of heavy loads with a small footprint. Even distribution. The load should be planned so that the weight is evenly distributed throughout the length and width of the container, with the high density of cargo stowed at the bottom and the low density cargo above. This keeps the center of gravity at the lowest possible point. While containers can be stuffed to their maximum plated weight, due considerations must be given to the container handling equipment and transportation asset capabilities throughout the journey. Additional consideration must also be given to the height of the containers in relation to the restrictions of the intended transportation mode. Additional factors to be considered for the movement of material by ESO containers include temperature during transit, and for some cargo it's also a limit by pressure it might endure, minimum nation or international security requirement applicable to the cargo, stability and center of gravity of cargo in relation to the load and cargo requirements. Contingency plans if cargo is delayed in transit, and at last national and international regulations requirement. Material handling equipment is normally used when cargo needs to be transferred from one mode of transport to another. Some material handling equipment is quite small, whilst others are extremely big. On this slide, you see some material handling equipment for loading, offloading cargo inside containers, and some heavy material handling equipment used on terminals to load and offload containers or a truck itself. A key loader is normally used to handle cargo going in and out of an aircraft and might be used to deliver specialized pallets in a quick way into or out of an airplane. In addition, you will find specialized material handling equipment in seaports as depicted here. Similar, you will also find in rail stations. Road movement operations in mission with good surface infrastructure provides a cost-effective, flexible, and reliable means of transportation for personnel and passengers. Use of road transport, where possible, should always be the first consideration in a movement planning. Several planning factors need to be considered to ensure road transportation operations are conducted successfully. Successfully planning means that convoys can complete operations and return for future tasking in a coordinated and controlled manner. Railways are unrivaled in their capacity to move heavy loads over long distances at a high speed and at a low cost. Transportation by rail should be considered wherever rail infrastructure permits. Railways are, in nearly all cases, built to suit the commercial requirements of a country. The capacity of a railway is measured of its availability to receive, load, transport, unload, and clear goods and personnel. In the case of rail transportation, capacity is measured between two selected points, such as a base area and a railhead. Provided there are no other limited factors, it is a product of the payload of the heaviest train and the number of trains per day that can be worked in both directions over the limiting sections. We are normally dividing airlift into two types: rotary wing or helicopters, which mainly are used inside the area operations, and fixed wing or airplanes, which might be used for strategic lift into the area of operation and inside the area. Fixed wing airlift is limited by need of infrastructure in the form of airports in order to load, unload, and it's subject to transit flights permission when overflying other nations. Airports are normally classified according to how heavy aircrafts the runway and the apron can support. When carrying dangerous goods, dangerous cargoes, or weapons, it's also subject to diplomatic clearance in order to overfly and land in other countries. Airlift is considered to be the most expensive method of transport and is limited by the size of the cargo hold for transport of cargo. Even if airlift is speedy, flexible, provides long range, and make it an ideal mode of transportation of personnel, it is often not the quickest mode of cargo due to the plane's capacity compared to a ship. When traveling over large distances with passengers, it's rare using any other modes than air. Sea lift is characterized by its ability to carry large amounts of cargo over long distances. Military cargo might be composed of equipment that is not well suited to be sent by an airplane or a train due to it being oversized or too heavy to get a good scale of economy in such mode of transportation. Sea lift, compared to its ability to carry large amount of cargo, is without doubt the fastest and the cheapest way to deploy large amounts of cargo. Sea lift is normally limited by the need of seaports during loading and unloading of the vessels. The type of vessels normally used for transportation military or police unit consist of the following types: wall-on, wall-off vessels, which is the preferred assets for all wheeled or tracked equipment and offers fast loading and offloading operations. Lift-on, lift-off cargo vessels can be divided into two main types. The first one is made specifically to carry containers. You will find that these are made in all different sizes, ranging from the ability to carry from 200 containers up to 20,000 containers. These vessels will normally be able to transport our cargo quite cheap if we are able to make use of the maximum carry ability. If we clearly see that we are not able to justify the chartering of the full vessel alone, doing so in cooperation with other nations might solve this, or we might use of commercial liner companies. Regularly scheduled container vessels cover most of the world. The second type of lift-on, lift-off, low vessels is made to carry cargo that is not necessarily packed in containers. This will be able to carry the same type of cargo as a ro-ro vessel, meaning that the cargo that is shipped on a ro-ro vessel might also be sent on a low vessel. The benefit of this type of vessel is that there are more offered in the market than the original ro-ro types. The disadvantage of using such vessel is that it takes a lot more time to load and offload, and in addition, you need to be sure that the seaport cranes are able to handle your cargo. Inland water transport can be operated on rivers, canals, inland seas, lakes, inter-island or limited coastal routes, and for ship-to-shore discharge. It is particularly suited to be carry of heavy and bulk equipment, stores, fuels, and bulk food when the time in transit is not of overriding importance. Many countries have natural inland waterway transport routes based on rivers and lakes that provide the only viable means of bulk transport. Many industrialized countries also have a good inland water transport infrastructure that should not be overlooked in movement planning. Inland water transport tends to be slow, but it's reliable, simple to operate, and can be a means of maintaining a regular, even flow of supplies. Limiting factors is the use of inland water transport are its inflexibility in the deviation from establishing routes and its vulnerability to enemy actions, particularly to bridges, lock systems, and dams. Inland water transport operations on inter-island and coastal routes can also be affected by weather conditions. Specific threat situations may require the use of escorts. In some countries, it's recommended to transport heavy cargo as main battle tanks on inland waterways instead of using road network. This is due to the strict limitations of how to use the road network. We have in this presentation introduced you to the containers, material handling equipment, and modes of transportation. Key takeaway: the 20-foot equivalent unit, the TEU, different types of containers for different use, the ESO standards for containers, safety certificate, and the different modes of transportation. Thank you for following this presentation.